Check, check. I thought I go wireless, but yeah, HDMI is great. Good morning. This is really great. Now I can say I met Matt from Meta, and my wife will be happy, and I will be happy as well, because she always wants to get the stats on how we're doing. So today I want to talk about generative AI in manufacturing. Who's in manufacturing industry? Okay, surprise. I thought that would be the minority at the Gen AI conference. Now, I will not talk about how Meta trained Llama 3, because you just heard an excellent talk on that. But fun fact, April 18 this year, this is Joe Spicek. He's from the Llama team. He was at our conference, which is called Fully Connected in San Francisco. So the very day they announced Llama, we also had our conference, and we asked him, could you just announce it on our conference? And this also describes how we work together. It's a very close collaboration that we have. We also have PyTorch, Torch Tune integration. So if you want to do fine tuning, you can do that very intuitively. Now, let's take a step back. Weights and biases. Yesterday, a lady asked me, oh, that's great, so you're in the fitness area. And no, not, yes, I love fitness, but weights and biases, it's a pun where you have the weights and the biases from the models, and this is the company name. So we have more than 1,300 customers, so enterprise customers. One of them is Meta, as you can see. All the foundation model builders, except one, use weights and biases, but also autonomous driving companies use weights and biases. German car brands, US car brands in Japan. There's smart tractors that also use that, such as John Deere. But what I wanted to show to you before we go into the manufacturing part is what is weights and biases about? So we have technology that we provide to enable Llama, for example, but also other foundational models. We have those customers, and then we have more than 1 million practitioners that use weights and biases, because it's so easy to get hooked. It's so easy. If you work in academia in a PhD, it's just pip install Weave or pip install 1DB, depending on what you want to do for LLM ops or ML ops. And then you already can get started. It's free for life, for academia. And this is then when people transfer from academia into industry, where they talk to us and they want to make this available inside the company. Often there's more challenges because you have enterprise-grade quality, such as authentication and a lot of boring stuff, compliance. We can talk about that with a margarita later, but this is where we help them. Now, this is me. I studied computational linguistics. And back in the days, everybody was like, yeah, are you okay? Do you need money? The grandparent would give me a lot of money each month because they thought I have no future. They had so much pity for me. Now, times have changed. So this is me in Berlin early this year at a conference. And this is the moment where I had talked to a CEO of a manufacturing company. And that's her. That's Nicola Leibinger-Kamüller. She's got a PhD in German linguistics, but she's also spearheading one of the most successful laser tech companies in the world. I talked to her. I was very nervous, and yeah, you're doing a great job. And she said, thank you. And then she ran on the stage. And yeah, I think this is really important, that you make those connections where, how does Gen AI connect to manufacturing? It seems that there is no natural connection, but I think there are many connections. So we met at the Bosch Connected World, which is where cutting-edge research and industry practitioners come together. And I love Venn diagrams, and this is where all the things come together. So Handelsblatt says that AI is used at Trumpf, but also Bosch is training AI with AI and saves a lot of money. So let's have a look at Trumpf, for example. They have an enhanced design process, which helps them to optimized parts. So they have laser cutters, but also some other fancy stuff. It's really exciting. They have 3D metal printing. And what they do is they collect the data to improve their systems. That reduces the design time, that reduces the manufacturing as well. And also they collect customer data, the real-time customer data, to improve the systems in flight. For example, Mercedes-Benz in their manufacturing plants, they have 400 of those Trumpf machines, and they continuously learn and improve the whole thing. Well, there has been this approach with Industry 4.0, Industry 4.0. It's been there for a couple of years now. And manufacturing is normally on the reactive and late to adapt side. But in this case, I argue that manufacturing can already save money and be productive with the Gen AI today. So I think that's really nice. Now, Bosch, what they do is they have an enhanced quality control. They use synthetic images to speed up the training for, that's KI, it should be AI. So they improve the reliability of their systems without having to produce the failure models. Imagine you have a valve or some other complex metal part, you have to produce the wrong part or find it to be able to create an image, and then you can train a system to recognize this. Now you can train an AI to generate defective parts, and with that you save a lot of money. What they say is they save 300 million annually in money. That's 800K per day. So you can have many caipirinhas for that money. And you can also add more employees at that money and still be cost effective. They have pilots in action. For example, based on a sample of a couple hundred images, they create 15,000 defect images. And with that, they could improve then different use cases for welding inspections. And now Bosch is seen as a leader in the KI innovation, in the AI innovation. So this literally gives me chills. Seeing Bosch, which was founded 20 minutes from where I was born, this is really exciting. But now people say, you read that on Handelsblatt, everybody knows this. We want to be surprised. Don't give us what we can already do if we subscribe to a newspaper. Okay, give me a chance. People say we are now in a new era of manufacturing. Here on the left, you have this shoemaker, manual effort, and then on the right, you have a production plant to do mass production. And if we talk about the evolution of the tools, then we can see that initially there was the manual design. People would sit down and get the blueprints, do the paintings. That's typical for architecture, where people are very artistic in creating new designs. Then somewhere in the 60s, 70s, or 80s, depending on the industry, there was computer-aided design. With CAD, people were improving on their systems. They could draw more accurately. They could simulate things, get a 3D image based on a construction CAD file that you have. My little brother, he's an engineer at a company called AMG. What they do is cars, very fast cars. And for them, to create those images that you see in prospects or some other testing things, many of them are CAD generated and saves them a lot of money. So it can easily adapt without going into the hardware production. And then we have generative design, which is novel, I would argue, and empowered by toolings, open source, such as Llama, but also others that can help in that area. And generative design is not limited to text or images. You can also create music for some reasons. There's a startup that creates free samples or samples of music based on a different description. So you have text to music or text to beat, and with that you can use that for your Instagram, for example, or your YouTube videos as a background music without paying the royalties. Now the question is, which one is right? We sure think that the manual design should be still there. We don't want to remove or replace that for all of the areas. For example, I have a colleague, he's from Geneva. Geneva, they love watches, and they still want to have this artistic approach to haute horlogerie. So they want to create and craft those watches and chronographs on purpose. I think for computer-aided design, if you build a nuclear plant, you don't want to just have a generative design and say, yeah, hopefully 80% is okay, and then the rest 20, we can have a fix and post-processing. I think there you should also be very careful. You should have all the guardrails. You have full control of what you're doing. And the amount of control as we proceed to the right is decreasing. So with the watchmakers, they have full control. They need a lot of time, but they exactly craft those watches as they are intended to be. And there's a lot of thinking that goes into this small timekeeper. For the middle section, for a nuclear plant, we also want to have that, but at such a scale you can't paint that manually anymore. You need simulations, but you need full control. And then for generative design, if you design a car, for example, where you have a very creative part, such as the initial outside design, the hull of the car, you want to have many ideas, and I think generative design can be a very enriching part here. And which one is right depends on the use case and also the company you work with, or the approach that you take. Now there's a couple of fun facts for generative AI, which are normally not talked about. AI is very much energy, has a lot of energy hunger. So there's a huge appetite, and we saw that in the numbers before that Matt shared. It's getting larger, context size is getting larger, the data is getting larger, there's more GPUs, NVIDIA's stock price is increasing until we see a change in paradigm. So a large GenAI model can consume as much as 5 cars over their entire lifetime. So this is the footprint many people are not aware of. And this is also why edge devices and having GenAI on edge devices is really powerful, because it saves a lot of energy. Then people think that many things that they see when they generate images or sound, that it's pure, originally novel. It seems that it's novel, but they are just combining things and remixing things. So having a horse on a spaceship eating a pineapple, this might not have been there, but it's just combining things that the element has seen already. I can tell my 5-year-old to do the same with these respective quality changes, but these are things where they just remix. What's also interesting is that you can get surprised. Sometimes you have a prompt and you want to have a very specific thing, and then you have this one element that just comes as a surprise. So I want to have a pineapple that sits on top of the Eiffel Tower, and then all of a sudden there's a mouse. For some reason there's a mouse. I don't know why, but that's interesting. Then there's also hallucination. I won't go into that. There's a huge evaluation research community that's dealing with hallucination and how to improve that. And then there's also the thing with bias. Generative AI models, they can amplify bias. If you train your GenAI model on Charlie Chaplin movies, for example, then you would have more people with a mustache or more men with a mustache than you had if you trained them on the Friends TV series. So yeah, I think we can move on. What I wanted to say, this is we work with real customers, and here we have a leading robotics manufacturer, and what they have, large collection of unlabeled images, And they want to find in this data set the right images. And it's very specific. They produce valves and cylinders and pneumatic technology. And what they do is they automatically label those images, and they use multimodal models to describe those in natural language. So for example, give me a system, a pump, which has 3 cylinders, which are red and blue. And then based on the description, they can find that in the image, rather than browsing through thousands of images. So there's a quantitative impact for them. They have a high quality data set, which is labeled. And they also have a good approach on the metadata. So it's searchable and helps them to create subsets of those data sets. And this overall improves the productivity. And what I'll tell my 5-year-old daughter later today is that with Gen AI, I have to show her some images and text, she knows how to read, that you can improve traditional tool design and really reduce cost along the way. Now, I took this image that we see on the left, and then I asked a large language model to give me a description of the image. First one is like poetic, in a cathedral of steel and sparks, and so on. I'm not familiar with that kind of poetry, but this is what you can do. So just based on this image. Then the next one is, give me a matter-of-fact description. So the industrial robotic welder is a high-precision automated welding system. Could be like a 90s commercial for some welder, where the CEO himself is doing a video. And then I said, extract only keywords for me, the metadata, and with those words, we can then do things. And this is what they do. It sounds very boring, but for them, it's really a booster in productivity. And another one is where we have a leading automotive manufacturer from Germany. What they do is they improve the battery welding for electric cars. So they increase the weld strength. They also reduce the energy consumption because they now go specifically to where the errors are. Initially, for the training data for them, they have experts, most of them are PhDs in manufacturing, label those data, because even for humans, it takes a 3-month training to spot those little errors in production. So they have increased the welding speed and the welding quality, and also reduced the defect rates. So this is, if you think in pure metal, this really has improved their overall production costs. Some people ask, what's the roadmap? What's the roadmap in AI? What's the roadmap for Gen AI? I think Matt already gave a hint. There's many more things coming down the pipeline. The roadmap for AI in manufacturing looks like this. It's really not there. I asked people, I talked to the customers, and they are very they know it's like a teacher who just knows enough to survive the next lesson and has like a 1-hour advancement in knowledge. We don't have that roadmap. Now, without a roadmap, we have challenges. Data quality is a challenge. We have, in those manufacturing systems, we have integration with legacy systems. I spent 7 years at an enterprise company, a German enterprise company called SAP. They do software. They're not even in manufacturing themselves, but they have legacy systems that are 45 years old, and oh, the data looks wow. Just looking at the data, that was really a downer. And then there's those people that are resistant to change. Why should we change? This Gen AI, that's just another hype. We survived blockchain, we survived the Web 2.0. Why do we need to do this? Go give me a printout and I'll give you a good design. And this is where the problem, in our perspective, is very clear. It's chaotic. If you train models, they lack visibility. And if you have experiments, they are very much disorganized. So it's chaotic. And this is where weights and biases comes in, and that's our CEO, Lucas Biewald. With weights and biases, for example, you can track everything. You can automate the boring stuff, including the chaos. And all the GenAI steps that you have that are not near to a pipeline or a workflow, you can get that organized pretty easily. Now, what is the impact of adopting weights and biases? This is what people tell us. You have a higher number of experiments, both in the models part, if you train your own models from scratch, but also if you do GenAI consumption, you just have a higher speed. You reduce the infrastructure costs, and you increase the accuracy of the existing models and also the future models. You don't spend a lot of time, or at least you spend less time, on boring work. How to track an experiment in a spreadsheet that really sucks, or some other things. How do you create the right visualization? These things should come out of the box. And how do you version data sets? This is really, I had to do this when I worked in machine translation. Now this can be automated. And you need fewer people, and this is not to save, to rationalize people away. We talk to customers and say, we can't find more people. If we had the chance to hire more people, we would do this. We have the budget, but we don't find the people. So helping them in their need to already, with the people they have, produce production-ready models. And you also get the full model lineage, which is important for explainability, for example, and reproducibility, and for legal reasons as well. And then we have weights and biases weave, which is the LLM ops part. This gives you the ability to track and trace all the interactions that you have with an LLM. So if you want to use Gemini 1.5, you can track all of these interactions, or with Llama, you can do that. You can increase the accuracy. You can manage how the hallucinations of your model work, so you evaluate that systematically. And with that, you can really protect your intellectual property. That's important. And along the way, you save money, and you are faster to do things and focus on what you can do. So here's a couple of real numbers. I can give you the names of those companies when we talk outside. For example, we have a Fortune 10 device company, and they have 2 to 5x the number of experiments that they can run, just by setting this up once. There's another company that went from managing 10 machine learning experiments to more than 100. There's another one that went from 8 hours in their entire pipeline to 20 minutes. And this is one of the hidden champions that is in the south of Germany. Then there's another one, automotive company. They have 1 million plus ROI after 6 months. So they already have the budget set for next year because they save money as we speak. And then there's another US tech company that saves 15+% in infrastructure spend. You don't have to work at a company like Google or Meta to know that 1% in infrastructure is a huge saving, and 15% was really a game changer. And that's what some people say is a good deal. Now we have time, 7 minutes for questions, and I'm happy to throw the mic at anyone who lifts their hand.
Hello, very inspiring talk. I really like the ideas you brought up. One thing I was questioning, I just supervised a thesis on the question on if we can do this use case one thing which you mentioned. So you essentially take a model, you auto-label, and then you ask a visual language model about what is in the image and is it good, stuff like that. Like in my experiment, we did Lava Next and ChatGPT GPT-4o up via API, and it turns out that the answers are just slightly better than a coin flip. So it just didn't work at all. And we asked all kinds of questions. We did a lot of prompt crafting. The models were not able to localize objects. The models were not understand which of the two objects which are of the same type were meant and stuff like that. So it was a complete mess. Didn't work at all. Did you fine-tune this model in this use case, or is this a hypothetical use case?
Thanks. Yes, people nowadays say, don't do fine-tuning, just use things out of the box. Yes, fine-tuning helps. Also having a high-quality small bootstraps data set helps a lot. So investing maybe one person 1 week in doing high quality annotation, you can do that also assisted with an AI. So just pre-train or generate some, redact that. So you have you can also compute the what we call the post-edit distance. And with that, you already have a metric that we can measure the performance. And that worked quite well.
Any other questions? I mean, Matt is anyway there, so it's not a problem. Okay.
All right.
Okay.
I'll be around the entire day until 5:33. Thanks.
Thank you. Thank you.